So now let's check the next question. The following data are obtained for the reaction given. This is the reaction, and this table indicate the data that is derived based on this reaction, and we have 5 numbers of experiments here, and we expect the rate constant to be the same, right? Now let's simply move to the solution. So the first steps is I'm going to write out the rate expression for this reaction, or let me just simply say assumption. Let me just say assumption rate law, rate expression for this reaction. Since this reaction contains 3 reactants, that shows that it is a more complex form of the one I solved earlier, right? So now let's move to the step. So we're going to have the rate here. The rate is going to be rate constant K multiplied by what? Concentration of bromine ion, right? And also that of what? Of bromate ion, right? Then multiply by that of what? Of hydrogen ion, right? So that's what we're going to have. But most importantly, the power of bromine ion is going to be raised power of x, that of bromate is going to raise power of y, and this is going to raise power of z. So that's actually what we are going to be having for now. So what we are going to do here is that I'm going to actually bring out 2 experiments each in order for me to solve for x, y, or z. But always very important that the first steps is very important, is actually for us to solve for the value of x. That's the first steps. So that's the first step I'm going to do. This is our first thing that to do in this case. So solving for the value of x, I have to pick 2 experiments that actually have similar value for bromine, for bromate, and also what? Hydrogen gas, because I have to cancel y and z out in order for me to solve for x. So in that scenario, I will be picking 2 reactions that are actually similar in this case. So for experiment 1, this is 1.8, and you can, if you go for experiment 1, right, which is 1.8 in this case, right, and 3.2 in the case of hydrogen ion, right? So, and at the same time, it is also 3.2 for this case. That's why it is the same. At the same time, also it is the same for this as well. So I can go ahead and pick experiment 1 and experiment 2 in order for me to solve for what? X. So in that scenario, let me just simply put experiment 1 into this rate expression. So I'm going to have this to be 10.4 multiplied by 10 raised to power what? Minus 4. This is equals to rate constant K, then multiplied by bromine is going to give me, that's going to be 9.2, right? So I'm going to keep 10 raised to power minus 1 here for now. So I'm going to have 9.2 raised to power what? Of x, then this is going to be bromate as well. I'm going to have it to be 1.8 raised to power what? Of y. So I'm going to be keeping 10 raised to power minus 1 for now, and this as well I'm going to keep in 10 raised to power minus 1, so I'm going to have 3.2, right? So I'm going to have 3.2 raised to power what? Of z. So this is our equation 1, right? So now the next one is actually the equation 2, which is the experiment 2 that I'm picking here. So I'm going to have this to be 2.6, right? Multiplied by 10 raised to power what? Minus 4 here. Then this is equals to rate constant K, then multiplied by what? In this scenario, I think I'm going to be keeping all these powers as well. So I'm going to be having 4.8, right? Raised to power what? Of x, then followed by 1.8 that I'm having here, raised to power what? Of y, and also followed by what? 3.2 raised to power what? Of z, which is what you are seeing here. So that shows that I've successfully fit equation 1 and equation 2 into this rate expression. So I'm going to have this one to be equation 2. So let's go ahead and solve this question now. So here, the rate constant is always the same. I'll cancel it out. Then that shows that everything here is actually going to be cancelled out. Everything here as well is also going to be cancelled out. If I divide equation 1 by 2 in this case, 1 by 2, that's actually what will happen here, because equation 1 happens to be the to have the largest value here. This is 9.2 and also 4.8. So I'm going to divide equation 1 by 2. And by doing so, I'm going to have 10.4. Then this as well is going to cancel out. Then I'm going to have divided by 2.6 is going to be equal 9.2 divided by what 4.8 in this case, all raised power what of x, right? So that's what I'm going to have. So now let's go ahead. 10.4 divided by 2.6, so that's going to give us 4, right? So approximately 4, right? This is also equals to 9.2 divided by 4.8. That should be giving us 2, I think so. 4.8, that's actually 1.9, and that is approximately 2, right? So here we're going to have 3 raised power of x. So that shows that I can have this to be 3 raised power of 2, which is also 2 raised power of x. So therefore our x is equal to what? 2, right? So that shows that in this case I'm going to have our a, we're going to have our x, which is the power of what of the power of the value of x, which happens to be the power of bromine ion, is actually 2. So that shows that we are going to have it to be what? To be 2. Now that's just it for the first one. Now the second step is actually to solve for what? For the value of what? Of y. That's going to be the second step, to solve for the value of what? Of y. That's going to be our next step. So let's go ahead and solve for the value of y. Now the next one, which is the second step, to solve for the value of y. So in order for me to solve for the value of y happens to be the power with respect to bromate ion that we have here. So that's why I have to pick equal value for what? For x, and equal value for what? For z, so I can cancel them out. So in that case, let's check the equal value of what? Of x that we can have in this case. So that happens to be, let's check the first one. We have experiment 3. We go for experiment 3 and 4. No, that's true that we cannot go for experiment 3 and 4, but at the same time we can actually go for experiment 3 and also experiment 5 in order for us to cancel our y out, right? So if we go for experiment 3 and experiment 5, that shows that this experiment 3 and also experiment 5 on this hydrogen ion, the concentration is actually what? The same as well. So we can actually go for that. So in that scenario, what I'm going to be doing here is that I will actually like to fixing the value into what? Into this space. So here I'm going to have it to be, let's say the rate is going to be, that's 5.2. I'm keeping 10 raised power minus 4 because it's actually the same here. So which is equal to raised constant, then multiply by what? Br minus, which is bromine ion, is going to give us 2.4. So I'll be keeping this 10 raised power minus 1 as well. So I'm going to have 2.4 raised power what? Of x, then multiply what? This bromate ion, I think the powers are actually different, so I can actually bring it out. So I'm going to have 9.0 multiplied by 10 raised power what? Minus 2, right? So that's what I'm going to be having in this case, raised power what? Of y. So then followed by, here I'm going to have 3.2, which is the case of hydrogen ion, which is 3.2 raised power what? Of z. So that's what I'm going to have. So I can call this equation 1. Then bringing out equation 2, which is experiment 5 here in this case. So I'm going to have this to be 2.6, which is equal our rate constant, then multiply by what? This is going to be giving me 2.4 raised power what? X, and this as well is going to be 1.8 times 6 power what? Minus 1, which is in the case of bromate, which is this and this. We look at it respectively. So then the next one, I'm going to have this raised power of y, then followed by, this is actually 3.2, right? So that shows that the corresponding second value is going to be 3.2 as well. So I'm going to have 3.2 here. I'm going to have raised power of z. So that's equation 2. Now the higher value here is actually equation 1. So I can actually divide equation 1 by 2. And dividing equation 1 by 2, that shows that in this scenario, our rate constant remain the same, is going to cancel out. The value of this as well is going to cancel out. Then that of this will cancel out as well. So I'll be left with 5.2 divided by what? 2.6, which is equals to, here we are going to have 9.0 times 10 raised power what? Minus 2 divided by what? 1.8 times 10 raised power what? Minus 1. And in this case, it is raised power what? Of y. So now let's simplify this. Let's see what we're going to have. So here we should have 5.2 divided by 2.6, right? So everything here is going to give us 2, right? Is equal. So let's see everything here as well. Let's see what's going to give us. So we're going to have 9.0, then multiply by 10 raised power minus 2, then divided by, we're going to have this to divide by 1.8, then multiply by 10 raised power was minus 1. Let's see what we're going to have. So we're going to have this to be, that's 1 over 2. So here we're going to have 1 over 2 raised power what of y. Now, so this is how we like to solve this question. It's very, very simple. I can actually rewrite this expression as 2 raised power of 1 equals to, look at this. This is 1 over 2. I can simply write it as what? As 2 raised power of minus y. Exactly, that's how I'm going to write it, because this is actually 2 inverse, actually 1 over 2, that's 2 inverse, but it's raised power of y here, so I can actually have it to be 2 raised power minus y. So in that case, this and this are the same, so I'm going to have minus y equals to 1. So therefore y is equals to what? Minus 1. Exactly. So y is equals to minus 1, so I can actually write it out here that y equals to what? Equals to minus 1. So that shows that the order of reaction with respect to what bromate here is actually what? Minus 1. Now let's move to the case of the next one, which is Z, right? To solve for Z, the value of Z now in this case. So that's the next thing we are going to do. So in order for us to solve the value of Z, we are going to put equation 1 and equation 2 from this experiment actually, and the equation must actually cancel each other out for this bromine ion and also for this bromate ion, and we have to choose the suitable one for hydrogen ion in order for us to get the power of hydrogen ion, which is the order of reaction here. So now in that case, what I'm going to be doing is that I will actually, let me check very well. So if I will be picking, I would like to pick, let me see, experiments 3 and 4 is actually the same for this case, but it is not the same for this case. So that's why I'm not going to pick it. But experiments 4 and 5 is the same for this bromine ion and also for this, and no, but not this. So I can actually go for experiments 4 and also what? Experiments 5, because it has the same value of what? Of bromine ion and also what? Bromate ion. So I can actually go for it. So in that case, I'm going to have the rate constant to be actually they're actually the same, they are the same. So I'm going to have this to be 2.6. I'm ignoring 10 raised power minus 4 or whatever. So I'm going to have this equals to K. Then I'm going to have bromine ion. I'm ignoring this raised power minus 1 as well. I'm going to have 2.4, right? So raised power what of X. Then here I'm going to have 1.8 as well. Raised power what of Y. Then followed by what? 6.4. So this is raised power what of Z. So I'm calling this equation 1. Now the second one, which is 2.6, is going to be equals to, I'm going to have K, then multiply by what? So here I'll be having this bad boy here to be also 2.4 raised power what of X. So this as well is 1.8 raised power what of Y. Then here at the same time I'm going to have it to be 3.2 raised power what of Z. So I'm taking this to be what? Equation 2. So what I'm going to be doing here is that I'm going to divide equation 1 by 2, divide equation 1 by what? By 2. And by doing so, I'm going to have some bad boy here cancel out. So this and this will actually result to what? 1 equals to, I'm going to have this K we cancel out, then this as well we cancel out as well, this and this is going to cancel out. So I'm going to have 6.4 divided by 3.2, and that should be giving me 2. So I'm going to have 2 raised power what of Z. So I have to deal with this. I have to deal with it. So in order for me to deal with it, I can actually calm myself down and look at it very well. I know that according to law of indices, n2 raised power of 0 is actually 1. So if I have 1 raised power of 0 is 1, if I have 2 raised power of 0 is what? Is 1. So this is what I'm going to be using, 2 raised power of 0. So that's what I'm going to put in here. So I'm going to have 2 raised power of 0 equals to 2 raised power of Z. So this and this will cancel out. So therefore, Z is equals to 0. So I can simply put it here that Z is equals to 0. And Z is taken to be the order of reaction with respect to hydrogen ion. So it is 0 here. So that's just it about the order of reaction. So after determining the order of reaction, I cannot proceed to solve for the value of K, because K as well is very, very important. It's an important parameter because it is the one that is actually constant. That shows that okay, the constant or the rate constant for this reaction is this. So it is very, very important enough for us to determine the rate of reaction at each concentration. Now let's go ahead and solve for the value of K since we are done with the order of reaction. So let's go ahead and solve for it. Our rate constant K as well is going to be R for this, which is the rate, is going to be 2.6 multiplied by 10 raised to the power minus 4, right? All divided by what? Here we're going to have it to be 4.8 multiplied by 10 raised to the power minus 1, raised to the power what? Of minus 1. Then multiply again by 1.8 times 10 raised to the power minus 1, right? And this is 3.2 times 10 to the power minus 4 all raised to the power 0, and that's going to be equal to 0. And that's going to be equal to 1 actually. So now let's go ahead and simplify this and see what we're going to have. So in that case, if you simplify this, we're going to have K to be equal. Now we're going to have it to be, this is going to give us 2.6, right, times 10 raised to the power minus 4, right? Then here we're going to have it to be, then multiply by this 4.8 times 10 raised to the power minus 1, right? Then here we're going to have it to be multiplying, this is going to be 1.8, then multiply by 10 raised to the power minus 1, right? So that's what we're going to have. Then this is going to be raised to the power what? Of minus 1 actually, because the power of what? Of y is actually minus 1, right? So we're going to have minus 1. So from there we're going to have the power of this to be raised to the power what? Of minus of 2 actually, because the power is actually 2. I mean that of what? Of bromine ion. So we're going to have the power to be raised to the power of what? Of 2. So let's see what we're going to have. So in this case, this is actually 2, right? And this is what is minus 1. So in that case scenario, we're having the answer to be 2.0303 multiplied by 10 raised to the power of minus 4. So that's actually what the rate constant is, right? So now we have to bring out the let me say rate SI unit, that is the unit of what? Of this rate constant. So in that case, we're going to have K equals to rate is actually molar over seconds, right? Then this is going to be divided by what? So here we are going to have it to be molar squared, right? Then multiply by what? Here as we are going to have molar raised to the power what? Of minus 1, and here is actually what? Multiply by molar raised to the power what? 0. So that's what we are going to have, because the value of hydrogen ion here is actually what? 0, because the order is actually 0 order reaction. So you're going to have K here to be equal to molar over seconds. Then here I'm going to have multiply by, now look at this, let me simplify. If I'm simplifying this is actually 2 minus 1, and that is 1. So I'm going to have 1 over what? Over molar. So this will cancel this. So we're going to have K to be equal to what? Seconds. That's per seconds, right? So that's actually the SI unit. So I'm simply going to put per seconds here. Now from there, I think we can now answer the question that follows this experiment. So we can answer the question now. So now the first question, question 1, says we should determine what the complete rate law of the reaction. So if we are to determine the complete rate law using this expression, we are going to have our rates to be the same thing, that is rate is equals to K. The rate constant, which is K, is going to be 2.03 multiplied by 10 raised to the power minus 4, then per seconds. We are going to have BR minus raised to the power of X. X is actually 2, right? And that of BrO3 minus, right? So it is O3. So we're going to have this to be raised to the power of minus 1, because Y is minus 1. Then followed by, we're going to have the next one, which is what? Hydrogen ion, which is raised to the power of 0. So that's what we are going to have in this case. And that simply shows that the order of reaction here with respect to hydrogen ion is 0. Order of reaction with respect towards bromate ion is actually what? Minus 1. And order of reaction with respect towards bromine ion is actually what? 2. Right? So in case you don't see this hydrogen ion, let me just put it downward here. You're going to have H plus raised to the power of 0. So that's what we have. So then this is actually the complete rate law for this reaction, and that's it. Now let's go ahead and determine the molecularity of the reaction that we are asked for. Let's go ahead with the molecularity of the reaction. Molecularity of reaction is taken to be the sum of the stoichiometric ratio after you've checked that it is actually balanced. So the equation, this reaction actually represents a balanced redox reaction, because we cannot just balance this one using chemical reaction. because it has ion, and that's why we are going to balance it using what? Redox reaction, and it is actually balanced. So the molecularity of reaction is going to be that's going to be 5 plus 1 plus 6. So we are going to have 5 plus 1 plus 6, and that is what? That is simply 12, right? So this is simply 12. So that is the molecularity of reaction. Then from there, overall order of reaction. So we have to determine the overall order of reaction. That's the next one. And don't forget that overall order of reaction is taken to be the sum of order of reaction with respect to each reactant. Now the order of reaction with respect to what? To reactant of what? Of bromine ion, which is bromine ion. We are going to have it to be 2. Then plus that of bromate is what? Minus 1. Plus that of what? Of hydrogen ion is what? Is 0. Right? So in that case, we simply have the overall order of reaction to be what? To be 1. Right? So that's that the reaction belongs to what? First order reaction. That's actually what the reaction belongs to. So now the next one, we are asked to calculate another one. We are given the parameters here as follows. So what would be the rate of reaction? We are asked to calculate for the rate of reaction if bromine ion is what? 7.8 times 10 raised to power minus 2 molar, right? Then and also we are going to have it to another one. Let me just simply remove this one as well because we are done with the overall reaction. So let's just proceed now. We are giving bromine ion to be this. Then we are giving bromate ion to be 3.9 multiplied by 10 raised to power minus 3 molar, and we are giving hydrogen ion to be 4.2, right, times 10 raised to power minus 5 multiplied by 10 raised to power minus 5 molar. So that's what we are giving. So in that case, we are asked to calculate for rate using this expression. Rate constant is actually a constant value, and we have it to be that's 2.03 multiplied by 10 raised to power minus 4. That's what we have it to be. Then multiply by constraint of Br that we are given. This is bromine ion is 7.8 multiplied by 10 raised to power minus 2, right? 10 raised to power minus 2. Then we can actually close the bracket, and don't forget the power of what of this is x, and x is what is 2. So I'm going to put 2 here, right? Then multiply again by that of what of bromate ion, and that is simply we are giving it to be 3.9 times 10 raised to power minus 3, and that's this power of minus 1, and that of what of hydrogen ion that we are given, and it is 4.2 multiplied by 10 raised to power minus 5, right? And it is raised to power of 0. So that's what we have. So we can now simplify this expression further. We simplify this expression further and we solve it. We are going to have the rate to be, let me see, replace my calculator. We are going to have the rate to be, that's going to give us approximately 3.02. Then multiply by 10 raised to power minus 4. We're going to have molar per second, or it's a mole per MQ per second. So that's the answer that we have. So that's just it about this video. So if you enjoyed the video, please don't forget to like, share, subscribe, and don't forget to support me on my Patreon account. And at the same time, please do well to follow us on our social media as well, including Twitter, Facebook, Instagram, and also TikTok. We actually release more of educational videos on it, and I'm going to be releasing the integrated rate law, and at the same time I'm going to be teaching you guys how to solve for the half-life for first order reaction, second order reaction, and third order reaction respectively. But what actually happened here is that this overall reaction is actually the one that determines the order of reaction that has to do with bromine ion, bromate, and also what hydrogen ion. So whether you increase the concentration of all these things, you understand the reaction is what is first order reaction. So there is no way whether if you actually determine the rate of reaction at different concentration, you are going to be having the rate order of reaction to be 1. That's just it, except if you change any of the reactants. That's what can actually change the order of the reaction. So the rate constant for experiment 1 at this concentration will always be the same. So that's what I want you guys to understand. So the order of reaction with respect to bromine is what is referred as this 2. With respect to bromate ion, it's what is referred as -1, and with respect to hydrogen ion, it's what is referred as 0. So the overall order will actually determine the order of the reaction between all these 3 reactants, and that's just it. So thanks for watching.